All right, so we are officially starting. Welcome everybody to PyData DC. We're really glad you joined us when there are so many other things that could have taken your attention. My name is Paulo Martinez. I'm a data scientist at MetroStar Systems and an organizer for this meetup group. And today we're going to hear from Taurean Dwyer, who's product manager at NVIDIA, and he's got something really cool to show us. It's going to be actually a live demo. There's going to be some stuff that we might be able to play with. It's all super cutting edge, and this is the first time that we're doing more than just a PowerPoint talk at PyData, so we're super excited about that.
Hey, we did more than a PowerPoint talk last time too.
Yeah, we did.
Or I guess we did less than a PowerPoint talk last time.
We did something other than a PowerPoint talk last time.
Yeah, we did less than a PowerPoint talk last time.
We had great fun. That's all I know.
For context, I was the one that gave the talk last time, just so you know, so that's clear to the rest of the audience here.
And it was just a picture like this big.
Yeah.
Anyway, sorry. Please go ahead.
Let me just get through the script and then we can carry on. So I just wanted to let everybody know I'm recording the event. What's being recorded is the active speaker and anybody who shares their screen. If eventually we're going to get this up on YouTube, and now is a good time to announce that our first event where Peter Wang talked to us about Conda and environment management is on YouTube. I'll throw the link in the chat, but I'll also send it out through the meetups. The chat messages are not being recorded, so your interactions with each other are ephemeral in the sense that they will not be saved after the meeting ends. You can opt out of being recorded by not sharing your screen or not being the active speaker. And let me read you the PyData Code of Conduct real quick. So here's the short version. Be kind to others, do not insult or put down others, behave professionally, remember that harassment and sexist, racist, or exclusionary jokes and language are not appropriate for PyData. All communication should be appropriate for professional audiences, including people of many different backgrounds. Sexual language and imagery is not appropriate. PyData is dedicated to providing a harassment-free event experience for everyone, regardless of gender, sexual orientation, gender identity, and expression, disability, physical appearance, body size, race, or religion. We do not tolerate harassment of participants in any form. Thank you for helping make this welcoming, friendly community for all. I'm going to post that in the chat, and also instructions for how to report violations if you need to, and then somebody will do something about that. Just a second. There we go. And here are the instructions on how to report. All right. Next step, let's see if we have any announcements from our partners. If you don't, partners, don't worry about it. This has been a crazy week for all of us. So this is made possible by MetroStar Systems, which is where I work. It's also made possible by Capital One, NVIDIA, and Spell.ml. So let's see if anybody wants to make an announcement. Capital One, is Mike here? Do you want to make an announcement, Mike? I think that's a no. How about from Spell.ml? Alexi, is there anything you'd like to share today?
Yeah, actually, a couple of things. First of all, do you have screen sharing enabled?
Just a second.
Let's do it very quick.
Got it.
Okay, try it now.
All right. Very cool. Hello. All right. Hello, everyone. This is Alexi from Spell. You're going to be hearing about Rapids a lot from Torian very, very shortly. But we've actually at Spell, we've also done a good amount of work on Rapids. We actually promote it to a lot of our own users when we get on sales calls and things like that. We actually have some blog posts on Rapids. I will post these in the chat afterwards. We have one on ETL with Rapids, and then we'll have a second one on a survey of machine learning techniques involving Rapids that will come out sometime in the next couple of weeks. Still working with Mike on that one. But I'll post a link to this afterwards in the chat. But this would be after the talk, if you continue to be interested in the stuff that Torian is going to present, I think this would be a great additional resource to take a look at afterwards. Yeah, and I guess I should also say what Spell is. Hi, representing Spell, and Spell is a end-to-end machine learning platform, and we try to make doing machine learning at your organization easy. So if that sounds appealing, check us out.
Yes, they're also super cool, and I like them very much. I recommend getting in touch with them. Okay, so like I said previously, our speaker today is Tori Dwyer. His official title at NVIDIA is Very Big Deal, Super Cool Dude. He can tell you a little bit more about it later. And then after his talk, we'll do a Q&A, and then we can kind of do like a virtual happy hour. While Torian gets started, if you would like some free food, send me a direct message in the chat. I will send you a DoorDash code, which it's a gift card code. It's not a discount code. And you can punch it into DoorDash, and that'll give you $15 worth of whatever you want to order. Without further ado, here's your speaker, Taurean Dyer.
Hey everyone, my name is Taurean Dyer, and I prefer your title in many ways. So as you probably have guessed, I work at as a technical product manager for this company called NVIDIA, and I work on this project called Rapids. Some of you may have heard of NVIDIA, and it was really interesting when we picked these dates a few months ago. Like we were just like, all right, someone's got to get the post-election one. So what we're hoping to do today is to take your mind off of things if you're upset now, and hopefully give you something to play with if you're upset later. And if you're not the same subset of people, then hey, be happy like me and not watch the news. So to kick off, how many people here do know Python? There's a little button that says raise your hand, or you can go in the chat, because I'm actually looking at the chat on another screen. So awesome for dual monitors. But how many people here know Python? And okay, cool. And then how many people here do data science? And I'm using this to kind of gauge the crowd and see what's like, how high or low I'm going to go with this. But how many people here have ever had to do EDA, which is exploratory data analytics, whenever they have to, go through their, not a clue, nice, all the time. There we go. So today what we're going to talk about are two things at once, and it's a fire hose of information. So we're going to kind of segment this out. There are resources for you after. We've done a lot of work to ensure that the community, once you get in, is a quick start. But we're going to talk about one, GPU accelerated data science. What is that? Where it comes from? Why? Where does it fit? And how can you use it? And then two, we're going to talk about this concept of visual exploratory data analytics. And it's going to be a little bit more than what you may already know, right? Because some of us do this right now. So let's kick this off. So the first thing that we're going to do is, let's introduce you to your fun space, right? This is where you can actually join me in coding if you want, or you could watch me. We will be using one of the people in the Rapids ecosystem called Blazing SQL to kind of do a quick start launch for everyone who hasn't had a chance or may not have a GPU in their computer. But if you do have a GPU in your computer, we have you covered as well. And we'll talk about that in a little bit. Then we're going to talk a little bit about why Rapids and where does this fit in your data science workflow? Like, why would I even start to think about using Rapids? And then we're also going to start to go into how you can use Rapids. Finally, we're going to talk about, hey, listen, this seems pretty cool. If you're interested, join our community. It's not just people members. There are organizations that are building on top of Rapids. There are organizations like Spell who are building with Rapids, and we're really taking this by storm, and it's becoming a really awesome ecosystem in itself. And then finally, we're going to do what everybody promised, which is we're going to do it live, and hopefully. I'm going to try and keep this really entertaining. As Paolo said, we had a lot of people doing slides, and Eric already outdid me because he was ahead in the theater for a little while. But we're going to start with this, and hopefully I can catch up at the end. So there's going to, and I'm going to describe how we're going to do it live so that, and how you can continue on with your Rapids journey from there. Okay. So, and like I said, slides may be available, but we're going to try and do this in 20 minutes. It's probably going to be like 30. Okay. So the first thing that I want everyone to do is go to beta.blazingsql.com. And if you have a Google account, you should be able to quickly sign in. And if you don't worry, you can make one later. Just watch what I'll probably have on the screen is going to be hella entertaining. And what we're going to do is, you don't have to do this yet. I'm going to have another link up when we're going to do it, but you can, we're going to start looking at the app.blazing or the beta.blazing SQL ecosystem. So give me 1 second to switch over to that and bring it up. Yeah. So this is beta.blazing. And what beta.blazing does is it allows you to get a free GPU instance. It's a shared resource that you can just click into and immediately start going with Rapids, either Rapids Stable or Rapids Nightly. So I'm just going to click on it here. It's going to realize that I already have it open on this link. And look, I'm ready to go. I click Rapids Stable and I'm in a notebook, and then I can start importing the Rapids libraries like so. And as it says, you know, there's Rapids Stable versus Rapids Nightly. Rapids is now on 0.16, which means that if I do this correctly, misspelling. If I do this correctly, it'll tell me 0.16, hooray. But what Blazing also has are these great Welcome to Blazing notebooks that were written by, you know, some of my friends, Winston and Rodrigo and Mario and Kristen and Ronaldo and all the others on the Blazing team, Percy. And they are able to help you understand what's going on with Blazing. And what Blazing allows you to do is use SQL, you know, where Rapids is pandas-like, Blazing SQL is SQL-like. We will get into that. I just want you to see what it is. You can, if I get boring, you can just play in here for a little bit, have some fun. All right, so where I came in, you can also open up a terminal. And for those of you who don't know, and we will talk about this soon, you can then Git clone the repo that I have up here. I'll show it again. And in fact, I will paste this into the chat, where you can clone the repo if you want, or I have another link where you can just clone just the notebook itself. All right, so it's rapids-VDA after bit.ly link, and the notebook itself will be bsql-veda, and you can go on. All right, is everyone pretty cool right now? You know,
Torian, can you just repeat that? I kind of missed it because I was distributing codes, but I'm sure there are other people who'd love to hear it one more time. Just
okay. Go to beta.blazing.sql. So I'll type it into the chat. And not just send it to you, Paulo. And then what you're going to do is you're going to take this fun link here. And I'm going to send, and you can do a Git clone on it. So the Git clone this after opening up terminal and just typing that in, or you can wait and then later on in terminal you can do wget. Now, for those of you who don't know, Git clone just basically clones a Git repository. Wget just grabs the text from the website that this connects to and brings it in, which is actually a notebook, and it makes it super easy. All right, we're gonna get back into this. Don't worry if you didn't catch it the first time. Or you can watch it and ask me during Q&A. Come on. So let's start by talking about, like, what is Rapids? Like, why are we even doing this GPU stuff? Okay, so let's start with what it is, right? And what we know and love, right? Which is our familiar PyData data stack, right? We've got pandas where we bring in our data and we create a data frame from that. We do our basic preparation in ETL. We've got scikit-learn for our machine learning, and both of these can be brought into multi-node or multi-node with Dask, right? We've also have NetworkX for graph analytics. We have Py signal for signal analytics. And with these, you can start to train models with the scikit-learn, the NetworkX, or the SciPy signal library. And then finally, there's this whole visualization thing where we have both Matplotlib as well as the PyViz set of libraries, which include like Data Shader, Bokeh, HoloViews, ScanP, and the like. And for those of you, and all this talks to your CPU and pulls off the data from your CPU memory. So basically, you would do your analytics and your machine learning and your model creation, and at some point within your data prep, while you're doing your data analytics or in your model training, you'll then visualize. And this is people understand that. Who this, and if you don't, now you do. So what is Rapids? Well, Rapids takes those libraries and creates a new set of those APIs, I should say, and creates a new set of libraries that instead of talking to the CPU, they talk to pulling off the CPU memory. They talk and pull off of the GPU memory, and they run completely end to end on the GPU. So basically, you download your data, you bring it into cuDF, and from there until you export it out for some reason, it is on GPU. And so what you have is cuDF for, which is like pandas for your data prep and your analytics, cuML, which is like scikit-learn, cuGraph, which is like NetworkX. There's cuSignal, which still isn't on here. And then we start playing around with our visualization layers of cuCrossFilter, Py.Viz, Plotly, HoloViews, Data Shader, and the list kind of goes on from there. And all of this is GPU accelerated with Dask providing multi-node and multi-GPU support, which means that if you have one GPU, awesome. If you have many GPUs, even better. It tacks on like Voltron. And if you have multiple nodes, there are many different ways using the Rapids libraries that you can connect all those GPUs together to process larger and larger sizes of data sets. And that's kind of important because these GPUs, they allow you to do this because we have this amazing amount of bandwidth for our memory, as well as an amazing amount of, what's it called again? We have a lot of processors, so we can do parallel processing really well. We have a huge memory bandwidth, and we have really fast memory. And we've seen this, and why is that necessary? Well, because honestly, our data sets are getting bigger. Lately we are needing to do more and more trade-offs in terms of accuracy and speed, or figuring out new ways to pre-process our data so that we can, train it faster and better. And, as you go down, as our data sets get bigger, we're going to have more and more trade-offs for that, right? Our CPU bottlenecks, and oh my goodness, we need that memory bandwidth. So that. And this is not a problem that that data scientists didn't know about. So let's take a little trip down memory lane. So we started with Hadoop, and we all remember Hadoop clustering, right? Oh, Wilson, you're nice. Where we set up these massive clusters that have all these CPUs, and we do HDFS read and writes, and we query, and we do whatever we need. And that actually really helped scale out data science and data analytics. Then Apache was like, hey, listen, why don't we just do this all in memory? So we have one HDFS read. We run all our operations in memory, and that created an amazing speed up. And a bit ago, companies like H2O, they figured, hey, wait, GPUs are really fast to do these kinds of, we've been doing a lot of neural nets, and we were like trying to they figured out how to parallelize some of the machine learning algorithms and apply it to GPUs. And now you are using GPUs to speed up even the in-memory processing, but you still have some problems with this, even though there's a generally awesome speed up from that. And that is the back and forth read and write of the data itself, right? So at each step, just like with Pandas, scikit-learn, and others, you'd still have to go between each library and copy and convert, or at least at that time. And as you went through each step within it, right? And these discrete libraries, well, that was interesting. So what we did was we removed the copy and convert rapids, and we used Apache Arrow to unify our memory, which basically means that we pretty much went Spark on it. And now, instead of doing the copy and convert between each library, everybody reads off of Arrow, and everybody understands, and we're now able to keep everything on GPU, even though we're switching context like that. And what that gives is a tremendous speed up, because the biggest bottleneck at the time, in the biggest latency is a GPU and CPU read and write. And now we're able to keep everything on GPU in itself from end to end. And that's cool. So what does that mean for you? Well, it means that you can do more in the same amount of time. You can start to explore your data. You can find errors and bugs in your workflow and make fixes. You can, when your workflow is complete, you can actually figure out some things and just start to experiment and have some fun with it. And obviously, as much as we love just like sitting around and waiting for things to finish, maybe there's other things we'd want to do with our time. So let's take a look at this new GPU accelerated pipeline. So first off, Rapids is open source. Not only is open source, we actually interact with our open source community, and both people commit to us and we commit to other open source organizations. We're built on CUDA, which means that CUDA is NVIDIA's general compute language. And basically what we've done is, by building on CUDA, Rapids can run on any GPU that has Compute 6, which, yes, I know most people don't know what it is, but Pascal or higher GPUs, which means anything with a 10 series or higher, or any T, V, GV, or A series general compute processors. And if you know your cloud computes, or you have your or you happen to own one yourself, those are the high-end compute cards. Those cards will work. So anything with an M in front of it, or K, which is Kepler or Maxwell, sorry, you're gonna have to use either cloud service provider or just upgrade. But okay, great, you have this great technology stack. Why would I want to use it? And the reason why you'd want to use it is because we keep it familiar to what you already know. You don't have to learn any new code. It's mostly, we strive very hard to keep everything the same within Pandas, scikit-learn, NetworkX, or GeoPandas for spatial. That's basically how we'd love. We know you love it, so we're going to try and keep it the same. So what does that even look like? So here we have the fun Make Moons CPU cluster, right? We're going to do some DV scans on Make Moons, and it's going to make the moons, right? You import pandas, you make a data frame from the data, you import scikit-learn, you run the DB scan, and it predicts, and hey, look, this is what it comes out with, right? So what we're gonna do is and I want you to pay attention to this, the massive code change that's necessary for you to do the same thing in Rapids. So here, yeah, I know it's a lot. So here, instead of importing pandas, you are importing cuDF. And instead of importing scikit-learn, you're importing QML. And we'll go back to the other one just in case you missed it. That massively huge change. And yes, it really does work and allows you to work that quickly. So that means that your existing workflows, you are now able to quickly make them GPU accelerated with minimal effort. I'm going to throw a little bit of a monkey wrench into this, and I'm going to say one of the cool things about Blazing SQL is, and you'll see it within as you are exploring, is that they allow you to do something very similar with SQL in itself. And that allows you to, and that allows, and if you have any for SQL friends or maybe a client that you're using, you would then be able to help work on their workflows. And we've actually had teams that actually worked on that and had to deal with that issue before, and it made their lives a lot easier. So like I said, we're open source for the win, right? We contribute to these companies, and who in turn, they contribute back to us. And we have a great relationship with our partners, and we invite, if you are in the open source community, to come join us and see how, if you have a capability like Spell, how can we work with you, and how can we help enable your customers and your users to enjoy basically the speed ups that GPUs can bring. Because honestly and truly, the way to win at data science is really through the ability to do it fast, iterate a lot, and get it right, and then have a great user experience while you're doing it, right? So, and those are our goals. So I'm going to start talking a little bit about the community now. Does anyone have any questions? I'm purposely not deep diving into the libraries. The slide deck does have almost 127 slides where it will happily go through that for you, and we are not going through them all. But I'll be more than happy to share these slides with you. That'll go through all the algorithms that QML, QGraph, QSpatial, and QSignal have. That will give you performance updates. And one of the main reasons I'm not showing performance is because we're just going to go through it and you're going to see it. So does anyone have any questions at the moment? Yes, okay, so Keith asked, have you done many benchmarks to see where Rapids-based methods compare to regular versions? Okay, so the answer is yes. We in fact, if you go in our GitHub, which we're going to talk about in a second, we have notebooks that actually do just that for many of our algorithms. We had more, but we decided to focus on a few because notebook upkeep is a scaling problem. But basically, if you want to look at Rapids, it's not like we baseline at 5x. So if an algorithm is introduced into Rapids, one GPU needs to be faster than a 2x 20 core CPU cluster. And it needs to be 5 times as fast as that. We have algorithms that go 5 times as fast, 10 times as fast. We have algorithms that hit 100, and then we start hitting orders of magnitude. And I think some of our best performing algorithms are in the QGraph, and those hit literally in 1,000 times fast. And what does that mean? Well, for Walmart, they have a blog out called From 2 Days to 20 Seconds. And you're going to see some stuff with spatial today that's going to be really interesting. Now, you asked also, are there any methods for which they do worse due to overhead? And it does do worse when you don't have a lot of data. If you got 100 rows, there's time to actually send it to the GPU the latency that is you might as well have done it on the CPU, and we will be slower. But as soon as you get into anything meaningful, really, really meaningful that like, some of us work with on a day in, day out, you're going to immediately start seeing things. So like from cuDF, it's about 15 times faster across the board. So a 30-minute read on a data frame tends to be 2 minutes. And it's been, that's been a pretty interesting thing. Pretty consistent and interesting phenomena that I've noticed. And you're going to see that as well. It's not one-to-one yet. We are in 0.16. We have a very high, what's it called again? A very fast release cycle, but we're working on it. We're getting there. Okay, so I'm going to pause on questions. We're going to hit community because I think you're going to see some of this stuff and it's going to be really fun. Answer lots of questions. So our goal is to basically bring Rapids to everywhere. So like awesome peoples like Blazing and Spell, we love you guys, and we're so thankful for you to be part of our community and helping us out. People like Graph History who helped us in the beginning, H2O, we owe that. We owe a lot to you. But what and as we grow and as we start working with other vendors and other organizations to keep growing this capability, from cloud service providers to other people in the PyData stack to making sure that we keep things as end-to-end, like even your deep learning remains, you're able to actually just stay on the GPU and send your pre-processed data straight to your deep learning workflows. We're hoping that this becomes more prevalent, and as we say before, we're open source. We want this to be open. We want everyone basically be able to use Rapids. So if you are interested, you can start by these 5 easy steps, which are found on our website, rapids.ai. We'll send a link out to that at the end. But you can deploy on Docker, Conda, or several of your CSPs. CSPs are cloud service providers, so like AWS, Google Colab, Oracle is coming out with some, Microsoft Azure, who's a big, who's done a lot of great things with us. We have, so then, okay, great, I've installed it. Oh, and then of course you can quick start with app.blazing. And then, when you start this, you can quick start with some videos. We have blogs, we have GitHubs, but basically we have everything ready for you to just kind of get started and go. We also have a community to chat with, so we're very active on Slack, Google, and Twitter. You can tweet your awesome workflows to us. You can Slack any questions or ask any questions in our Google groups. And then, of course, we want you to contribute back. Like, it's open source because we want it to be open. We want you to share. We want you to help each other out. We're a community, and that's great. That's how you build an awesome and long-lasting community. So let's talk a little bit about the installation. We have a release selector. So basically, Rapids runs on Ubuntu or CentOS or any RHEL-based operating system. We do not run on Windows officially supported yet. WSL2, there's some good work on that right now, and we'll be pushing, when it comes more stable, we'll be pushing that a little bit. But for now, you have cloud service providers, you got Blazing, and of course, you can just dual boot or on a workstation that has a really awesome GPU on it. And here you can pick, either Conda or Docker, and we basically, at the bottom here, we give you the install parameters. You just basically copy that into the terminal and press enter. It's really cool and really easy. We also have documentation at docs.rapid.ai. These docs follow all our releases. You're able to flip through and search, and it's become a lot easier to use thanks to feedback from the community members. And we also have these in the docs. We have these awesome tutorials called our 10 minutes to X. You can use. You can start to look at each one of our our libraries and really just get a glimpse at like what does it take, how does it look, and how can you get the most out of it really quickly. We also have our GitHub, which you can go to at github.com/rapidsai. We have our code and blogs also on GitHub, but we do have a Medium channel for Rapids AI, and our release blogs and all these cool things that we are able to do and how to do them are there. So one of the things that we'll show at the end, there's a nice blog on how to actually do some of these things. And then we're relaunching Rapids Community Notebook soon. This is where if you have a workflow and you want to share it with the community, please do. And then finally, like we talked about, you can get the software at these places. You can deploy Rapids at all of these cloud service providers if you want. And please do join us in the end. Okay, so now you will be able to review. I'll be sending out the slides. This is the end of the slide deck. So now Paulo is going to get a big smile because he's going to actually be able to live up to his word of, oh my gosh, we've been doing slides, except for Peter, who just sat and talked with a big cowboy hat, which was freaking awesome. Oh, back, forward. Slides are out of order. All right. So, coding example. What we're going to do right now is if you've done your Git clone, or you are able to do the wget that I sent in the chat earlier, what we're going to do is right now we're just going to do it live. This is what everybody's been waiting for. So with that being said, so when you go to app.blazing, I'm just going to walk you through app.blazing for a second so that everybody's kind of on the same page. And then we're going to jump in. And this isn't going to take too long because we are Rapids. There's my mouse. There's Jupyter Lab. So assuming that you were able, yeah, I made my stuff really useful. Assuming that you were able to use terminal, and then you type in something like, actually, let me just come out one folder up. And then you type in wget, the wget command that I shared with you earlier. You should be able to quickly pull the notebook itself in its raw form. All right. Oh shoot. Use the Git clone. I didn't realize it would copy the redirect. But hey, that's why we do it live, right? Because we have to have this kind of fun.
I think it's just because the bit.ly abbreviation. So I was able to successfully do it. In my browser, I went to the link, and then when I did the Git clone, that worked.
Okay, let me bring the. I'm going to copy the.
Yeah.
I'm going to copy the repo into the chat, and then we'll just send it there. Thanks, man. One second, I'm trying to get to my repo.
So Keith also copy pasted the link in the chat.
Oh, yeah, awesome. So let me click in.
This is great, Taurean. This is high wire.
Exactly, right? This is what we came for.
Yeah, man.
Watch things go. All right. So I'm also going to do wget. All right. So let's show you what it should have done in the first place. Wget So refresh the terminal. Okay, great. And now I've got this notebook right here and it's ready to go. Oops, I opened the wrong one. Still live. And you should have a new notebook that says New York State NYC Taxi Spatial Notebook. Okay. Now there are two different copies. If you look at the Git Clone, one of them is for a local run where you have your own GPU, preferably one with more than 16 gigabytes of RAM on it. So everybody who's got like a Titan or a 3090 or any of the fun GV100s, y'all are all decked out. And if you want, you can even try it out on the paid version of Blazing, which it's pretty much 75 cents for an hour with that you can use it for, and you can actually like buy it right now and try it out. But we also have a Blazing SQL version, which instead of using, which uses a slightly different data set, and we're going to get into that in a second, okay? All right, so here's where it gets fun. So for those of you who have never used a Jupyter notebook, what you do is you click on the cell and you can click Shift Enter. Now, do not run everything right now. The reason why is because we are doing visual exploratory data analytics, and you're going to have to explore. So what I want to make sure is that you know that you click in here and you click Shift Enter, and it will run that cell. Make sure, by the way, you're running Rapids stable. Do not run Rapids nightly. There are special reasons why, because I wrote it for stable, and we want to make sure that everything works out for everybody. Okay. And like I said, there's a little bit of an instructional in case you don't have like a 16 plus, maybe you have like a 1080 or an older or smaller GPU that has like 11 or 8 gigabytes. Please do use this, the Blazing SQL version, and you have your ports here, and you should be able to run nicely. Okay, so I am dropping out of this and I'm going to my workstation. I'm going to run a very similar but different workflow, a longer workflow, which it'll be found in the second notebook. And we're gonna let's kick this off. Switching windows. By the way, you're all able to see my window. I'm not just talking to like.
Oh, have you been sharing your screen this whole time? I'm joking. We can see it.
This has actually happened, which is fun. It's Zoom fun, right? So here's what's going on. So for me, I'm going to be using the yellow tab data, the AxiCab data set, which is all the lovely little yellow taxis that we know. It's a data set that a lot of us who are playing around with data science know and love, and probably are sick of at this point. But we're going to look at it a slightly different way, and at familiarity is actually one of the reasons why we picked it. On your end, if you're using Blazing, you will be using the green data set. Now, remember what I said about Blazing having shared GPUs? If for some reason you run out of memory, and that's because we're all trying to be good stewards on these shared GPUs, but if we run out of memory because it is a sizable data set, just watch and you can try it out again later. All of this is available to you for free at any time that you want to use it. Okay. So what we're going to be doing is we're going to look at 4 different Rapids libraries. The first one is cuDF. The second one is cuSpatial, which is our spatial analytics. Third one is cuML, which we talked about. And the fourth is cuCrossFilter. And the cuCrossFilter part is going to be exactly why we named it Visual EDA. So let's kind of start in. I'm going to be importing our libraries. And I like to keep this around because I do share this notebook, but those are the IP addresses. And what I've done is I've actually downloaded the data ahead of time, which is why it's always found. But for you, you're going to be pulling from an S3 bucket that straight from New York State. So this is all real world data, because the best data is real world because it's noisy and we got to clean it out, right? So what I've done is for cuSpatial, we have brought the shapefile in, and we have then formatted it into a way that cuSpatial can read it, because cuSpatial has a special way of reading these files so that it can work at the speeds that it does. Okay, so we're going to check out the shapefile, because you're probably like, what do you mean? And here it is. So in New York, believe it or not, there are 5 boroughs. So there will be 5 shapes in the shapefile. And these shapefiles have features and rings, and then points for those within those rings. And you can see this is where it actually starts each borough in order, right? And here are the positions of the features, and here are the positions of the rings. And it's a very fun and complicated recursive way, which we do not need to go into right now. But what you can do is see that, hey, look, in the first ring, in the first feature and ring 1, these points here, these 11 vertices, make up that ring in that feature. So, but these actually have real world meanings, right? So you can actually see that this is our latitude and longitude here. And then you can actually split it up and break apart this system as you want, as you need to work on smaller subsets of it, which we did for the CPU version of this, but we do not have time to go through the CPU version, trust me. And here are the sets of rings in the first polygon of New York. So that these are the rings that go through. Nothing you really need. But here's the fun part. This data set is about 2 gigabytes. Let's see if I can find it in here, because I love storing and deleting stuff. No, I don't. So we'll just hover over. So it's 1.8 gigabytes. It's about 2 gigabytes. Your data set, you can download it if you want. It'll be less, but we're going to do a QDF read and we're done. That's how long it took to read a 2 gigabyte data set. We can count the data that's in here. And there's 12.7 million rows. All right. And these are the columns that go through. So now we have these 12.7 million pickup points. You should have 1.4, by the way, if you're running this along. But the actual, the shapefile should not change for you. So in case, what we're going to do is we're going to take these 12.7 million pickup points and these 12.7 million drop-off points, right? Stuff that we would love to go through as we, and manually check all of our data and start to put them in points in Polygon and into each one of these polygons so that we could put them into features. Why would we do that? Well, for those of us who don't know much, who haven't played with the New York State taxi data set, it's dirty. Because, well, basically you have buildings, you have skyscrapers in the way, right? You're going under tunnels, you're going to bridges, and these taxis, sometimes things don't click back the way they should, and you get a lot of erroneous data. So we're going to look into that a little bit as we go into the visualizations, but that means that if you're going to do any real data science, then you're going to have to clean this up a lot. There are many methods to do it that people have. I can link you to a few later on, but this is why we're doing it here right now. The first thing I do is, in case I have an incomplete download for some reason, we're just going to fill in the NAs of longitude and latitude. And the second thing we're going to do is we're going to do points in Polygon on each one of these longitudes and latitude, each one of these pickup points and drop-off points by their longitude and latitude. Now, what does points in Polygon mean? That means that if I have a shape like here, that if I'm basically trying to figure out where this point lands on the shape or a set of shapes. And that is a very expensive operation. So we're going to run this, right? Now, what's kind of really interesting is that the GPU I'm using is what's known as a RTX 8000. It's got a massive 48 gigabytes of RAM. And it's a Quadro. However, I also have dual GV100s with their compute cards in there. And this whole thing that just took 27 seconds runs for 3 seconds on that GV100 on a single one. Now you're probably looking at me like, okay, great, it ran in 27 seconds. I'm just curious, how many of you have ever actually done any spatial analytics on data science for data science?
Never with something this big, because it took so long.
Right. We have notebooks that you can run in your spare time, not long of your spare time, that literally ingest the entirety of the New York State taxi data set. Our mortgage data crunches through about 117 gigabytes in about 3 minutes and does XGBoost on it. So with spatial data, when I ran this on 10, I think on the CPU version, it was 10,000 points on a small shape. It took 30 seconds just to run against those 10,000 points on that very small bit of data. And when people do run it long, like the whole data set, you're talking about hours. So we have gone 3 seconds for something that would have normally taken hours to even days, depending on what your CPU looks like. That being said, okay, great. We just saved ourselves like a whole day. Let's keep going, because I'm just talking. So what we're doing is basically saying, okay, look, what did we create? Well, we created these arrays and these data frames, right, with the name of the boundaries. And now what we're going to do is we're going to make it useful for the other Rapids libraries by bringing it into our main data frame. So we're going to bring it back, and that was all that it took. It's done. And now we're reading it into the data frame itself. You have 2016, I have 2015. And as you can see, here it is. We have our borrow integers and our drop off borrows. Why? Because it's just, we'll see why in a second, but it's basically because of strings versus numerics and the speed of processing that. So, okay, great. Now, for the, we have all these longitude and latitudes now in the proper borrows. So what can we do now? Well, let's make some analytics out of it. Like, wouldn't it be great to see which rides were within all borrows? We're done. Now we have a column that shows which rides are in true or false, which rides are within both the pickup borrow and the drop off borrow are not external, because that's what we label the external borrow. We can keep going. Oh, and there it is, right? So start in Manhattan and in Manhattan within all boroughs. True, great. So let's even look at this, right? Let's start looking at like how these rides are, right? So this is 1 month. It's January of 2015. And that's how many rides happen in Manhattan, or used to happen before Uber. And you can see the lion's share of the rides are in Manhattan. So this data set is weighted heavily to Manhattan itself. Then comes Brooklyn, then Queens, then external, which means that at some point, one of the rides, either pick up or drop off, ended outside of the 5 boroughs and the Bronx and Staten Island. And then we can we can do things like look at just the pickup borough. And then what we can do is we can see which ones were within all the boroughs. And as you can see, 314,000 actually come outside of the boroughs. And then what we can do, which is kind of cool, is that we look at which rides happen between boroughs. And we just, because we have the pickup borough, we look at that. And, as you can see here, 1.4 million, almost 1.5 million actually happen, there are rides that happen between different boroughs in Manhattan. So about 10%, just over 10% of the rides are actually go between different boroughs. So people aren't traveling, from Brooklyn to Queens or from Brooklyn to Manhattan as much, but they are traveling and still using it, as necessary. So now we kind of, this is kind of like how we normally look at this stuff, right? Like we basically look at the data itself. We ask these questions of it, and we can go on, right? So now what we're going to do is we're going to clean the data a little bit more, but we're going to add some more features to this data frame, which is namely day and hour. And now we're going to do the big thing that I promised you all that we're going to do. We are going to get rid of all these external points and only focus on taxi rides that happen within the 5 boroughs of New York. And here we go. And we're done. Hooray, we finished. But that's not great, is it? No, it's not. That's pretty anticlimactic. Because we can, that's not what I wanted you to do. You know, we can see this. So what are we going to do? We visualize it, right? Because dear God, how are you going to check and make sure that everything happened if you don't actually know what's in your data and can actually see it? So the first thing we're going to do is what we normally do, which is go to data shader or anything in our PyViz library, you know, our favorite PyDis package. And we're going to use data shader because, as you probably know, matplotlib taps out, you know, about 10,000, and then you really are crying. And data shader is like this great way of quickly creating images of all your points and can handle millions of points really, really nicely. And since we are not pretending and we are going to be using the full data set because we don't need to sample because we're using Rapids, we're going to do it. Now, here's a cool thing that you may not know. Rapids actually committed a PR'd the GPU acceleration. So you don't even have to tell data shader that you're using a GPU. And here you go. Remember what I said? You know, it's kind of a nice little outline. You know, we got this great little fire thing. It's very visually appealing, right? But you see all these little dots in here, and you see all these dots out here. And this isn't even the full view of Manhattan, right? So what did we do? Well, now we're going to take that taxi coup spatial cleaned, and we're going to rerun it again. And we're going to make everything happen. And it's just showing us that it's running in real time. And look at that. All these things are out, and that's really cool, right? Like, look at that. We can look at this image, and then we look at this image, and we're good, right? Are we happy with this? Yes, no? Just write it in the chat or nod your head.
Yeah, can I just stand on you a little bit? This, for those of you who, if you missed it, I loved this, right? Because I often do this sort of thing, but I have to do it, you know, like with like logical checks. I loved that I could just be like, show me what's wrong with it. And now I can, you know, like figure out what I want to do next. So love it.
Yeah, thanks, man. But now that's not good enough. So what we're going to do is we're going to take these points and we're going to put this into coup cross filter. And let's see what that gives us, right? And what kind of experience that gives us. So first off, we're going to import coup cross filter. It works with bokeh, which allows us to create a dashboard. We're going to run the same operation that we did above, where we're going to take the actual data frame and, you know, we're going to have our longitude and latitude. But then what we're going to do is we're going to be bringing in bokeh's tiles. And what are these, right? So now we're going to actually launch our dashboard. Now our dashboard, we got a label map. We don't need this anymore. This is kind of an artifact of old, but you know, this allows you to identify the integers that are in here that represent the boroughs. And you're going to have your pickup points, your drop-off points, and then these things called multi-select that allow you to do pickup point integers, day, time, and month. And I'm pretty sure you can kind of see where we're going with this. So now what we're going to do is we're going to run. And it's going to create this dashboard with all the charts that we created above. And you can look at the code. And we created all these different looks. And then I click this button. And I wonder what we get. Now, I'm running this on a VPN. This is not eating the electricity on my house. And each one of you should be able to see something very similar when you run this in your Blazing SQL notebook. Now, what's interesting about this is, great, we got pictures, and this is wonderful. But what can I do with these pictures? Well, first things first is I can zoom in. And now I can get a really good look and pan around. And I can get a really good look at where all the mob bodies are buried, right? After these hits in the middle of the Hudson River. And the second thing that I can do, and like I said, this is latency. It's on work on my actual work VPN. And it will catch up, is that I can actually start to filter out things. So how do I clean this in spatial? I literally just highlight. And you can see that the charged things are disappearing already. And I highlight over here, and I select what I want to see, and now everything's done. So now visually, I'm able to look in, and I can see where all of these points that were noise or seemingly noise in the data shader, I can verify that they are not noise, and that's where the taxi pickups were for here. And the other cool thing I can do, and we're going to play with it a little bit more, so I'm not going to shut it off, is I can take what I see here and I can export it into a whole new data frame. And then I can start working on that data frame. So you see here, I exported, it queried, ran the query itself, brought it in. I can now see it. And then the rest of this area right here is just a little bit of, oh my goodness, let's just do a sanity check. And this right here says, are all your numbers the same? The only ones that should be different are the pickup and drop off point XY, because those were done to only a few. And then right here, it just counts the differences. So here we saw two really quick ways of cleaning your data. One programmatically that we're all used to doing, and is GPU accelerated, so we could do it really quickly. And then another one where we took a visual look at this data in the middle of our workflow and just said, hey, listen, I just want to see X, just this. And I can do that ad nauseum and start to really look at how people travel. So we're going to ask a couple of questions and we're going to move on this. But here's Brooklyn and here's Manhattan. And here are all the rides that go from the pickup point of Manhattan, somewhere in Manhattan, and end up in Brooklyn somewhere. And it gives you the amount of rides that there are. And then you can do fun things like figure out, change the day. You can change the time. You can multi-select all of that. So fun little quiz I like to give everybody. This is January. The ball just dropped in Times Square. What do you think, and I'll let people have some guesses, what do you think happens? When do you think is the hour that the most taxi rides happen after that ball dropped? Just type it in. I want to see this. Okay, so this is 10. 1, 2, 3. Brandon, you're just adding, throwing numbers now. All right, cool. So let's actually look at this, right? And I should probably zoom out a little bit so you can kind of see. Don't break. All right, let's keep it there. Come on, let's do it. Okay, so for those of you who said, so this is the hours from 0 to 1 o'clock. So we got 13,000 rides. Oh, I'm sorry. From Manhattan to everywhere. That's what I really should have asked. There we go. And now it's all back. 13,000, no, now it's 25,000 rides. That should be what I said before. 1 o'clock, 26. And watch me mess up my own demo. There we go. I knew I was going to do it. Stop. 2 o'clock. And you can kind of see it. And this is normally something that you query, but it's kind of fun to see, one, where the rides, the actual map change. So you can start to see where the rides are and where they end up. And basically 3 o'clock, and you'll see it goes down. So what you get is 1 o'clock. Everybody's coming through. 2 o'clock. There's less. So 1 o'clock, yeah. Between the hours of 1 to 2, that's the most amount of rides that happen in New York City. And you can see that they basically go everywhere a little bit, right? And that's kind of fun. And you can kind of start looking at things like rush hour traffic and how people go between boroughs. It's really interesting to see where people end up as you get later on in the day, like 5 o'clock, 6 o'clock, 7 o'clock, as people jump from party to party because we're New Yorkers and we love to party. I am from New York. So does anyone have any questions?
Yeah, we have a few in the chat that I've been trying to keep track of. So a while back we had, I think, Keith, you were asking something. It was back about if you were planning to release this in any other distributions. Let me just find that real quick.
Oh, this is released. You have it. I gave you the GitHub.
Cool. And then we had another one recently. Let me find it. So somebody wants to know where you found the data.
New York City Taxi is part of the TLC. You can actually, I think I say it up. I may have been a jerk and didn't say it up here. So I'm not able to. 1 second.
It's a public data set, right?
Yeah, it's a public data set. So NYC taxi is right here. By the way, this guy right here, he actually did it using CPUs. I can share that link later. It took a long time. Let's just put it that way. You can literally pull it from here, and here's all the data that they have. I think it's like 250 gigabytes or something like that worth for every single month, for even for hire.
And we have another question where somebody's trying to figure out, I think, like what this is doing under the hood. So the question is, okay, so did I get this correct? When using conventional data tools to use the GPU, we move data back and forth to the GPU. Mm-hmm. This is a re-implementation of some of the common data tools so they can stay on the GPU, right?
Exactly.
Cool. And then here I found Keith's question. Thanks for posting that again, Keith. If there's any plans to support non-Debian-based Linux distributions.
Well, we have RHEL and CentOS, but I don't think right now, no. It's on. There's a lot of feature requests, and we love to see feature requests. The issue is obviously we're a small team with like a 6-week push between releases. So until we get to that 1.0, then
Somebody else was wondering, and I don't know if you know this or if anybody in the group does, throw it in the chat. If anybody knows how Seaborn fits into the scale between matplotlib. So the question is, how does Seaborn fit into the data set size limits? You mentioned matplotlib handling smaller sets and data shader for larger data sets. I don't know if you know that.
So we actually do, in my data set that I have in the larger one, we will be looking at Seaborn at 40,000 points. Not sorry, 40,000, 400,000 points. I think it's I don't really know the exact numbers. Alan does. I don't know if AJ is on the line, and he does too, but they gave me a lovely little overview on server side versus client side versus how much data each one can handle without going, oh crap.
Eric had a great answer, which was that Seaborn is just a wrapper around matplotlib, so same limitations. We have a great question, a good, like fundamental. What's the distinction between using a CPU and a GPU?
So GPUs have lots of slow processors on them. These are CUDA cores, and then a CPU has a few large processors. And what we found, especially in high performance computing, is that if you can break up your tasks and run them in parallel, you will be able to do much more work really quickly than if you have just one or a few compute cores going on a CPU. So think about it this way, right? You can have one person who's like really, really fast at building a house, or I'm sorry, not even building a house. You can have one person who's really good about cleaning up a room and picking up stuff, or you can get like 10 or 100 people picking up stuff and cleaning up your room. Who do you think is going to finish first as you scale up more and more people? No matter how lazy they are, like me, they'll finish first. So I'm going to pause on questions for a second because we're just getting started, and I know that people want to go. So I'm going to blaze through this next part really quickly, because the next thing is the really important thing is actually what happens. Great, we did it during EDA. What happens when we do it during our machine learning sessions? So let me just get to that, and then we'll open up for more questions, and I'll be done. I have one more slide to show you, because this is for the data scientists, and we're going to talk about how you can. We're going to touch briefly on how you can do this for your for specialists, like you're a programmer, right? So basically, what I've done here, and you can look, is just do some analytics on the rides themselves. You know, for time of day and when things are done, and how many rides happen per hour. And this is all fun, but then we said, hey, wait, we cleaned this, right? And look at this, like, oh my goodness, the distances are in millions of miles. Well, that means that not all our data points were actually cleaned out, and not all the errors were due to GPS only, right? So let's take a look at this, and we're just going to quickly do this so that we can do some machine learning on this data set. So as you can see, we've done a distribution on just a trip distance. We're using Cross filter clean right now because, you know, we're loving it. I already deleted it. And here we can see our max is 1.5 million miles, and that's a lot. So we got to get rid of some of these. So what we're going to do is we're going to say, hey, listen, New York State, the New York State boroughs is not that long and not that big, so we're going to keep it under 100 miles. And because basically, you know, 75th percentile is 3 miles, so that's good. Now we're going to describe this data set, this data frame, and as you can see, it's still 75%. So, you know, this max is pretty okay. Now what we're going to do is we're going to use Spatial to get the Haversine distance between things. We're going to between the pickups and the drop-off points, and then we're going to just do some more daytime, year, and month, you know, feature creation, and we're going to also have a compute distance function, and we're just going to run those, and we're going to time them. And then here we're just forming the data set because we're going to use k-means, and k-means only can run on numerics. Remember, we were talking about the importance of numerical data, and we wanted to keep that. So we have dropped all the things with letters in them. All the strings are gone. And now what we're going to do is we're going to train on k-means on the entirety of the one, you know, what remains, which is like, I think it's like 1.243 million rows. No, I'm sorry, 12.2.3. Yeah. And it's done. So now we've got our clusters. And as you can see, our clusters are very different than what we were looking at before. It's not based upon, even though there are 5 clusters, it's not really based upon the boroughs of Manhattan. And now here's what we normally do. We normally take something like Seaborn, Matplotlib, or anything. We take some samples. We find some times that we are of interest, and we look at it, and we say, okay, great. And then we make these awesome, you know, cluster diagrams that show us where our clusters are, right? And how many of you are happy with this? I mean, it's good, right? It tells you if it's a short trip, true. If it's rush hour, true or false. And you can kind of see like how these clusters are going. Well, as you probably guessed, there is the cross filter way that we're going to be doing. And so we're going to delete this guy right here. We're going to describe the distance just so we have it just pretty clear. We got our counts, and then we're going to skip the actual thing I needed. And now we're going to have 2 charts. The first one is going to be our k-means clustering, which hopefully looks pretty much like this, because this kind of looks like something. And secondly, we're going to also on the side have the original pickup points and drop-offs. But then what we're going to do is we're going to be able to select between cluster, trip distance, Haversine distance, whether or not it's weekend, pickup hour, day of the. We're basically just going to be able to like play with this. And like I said, we're not going to fully play with it here because we are low on time. But then you click it. And you wait, and there it is. And now what you can do is, okay, great, I got a similar cluster. This is interesting. But what's kind of, not only can you now click through the different layers, you realize that the clusters are on top of each other. Right? Oops, didn't mean to click that one. I didn't break anything. There we go. And then the other cool thing is, obviously, you can zoom in. You can change your trip distance. And that's going to drop down as I was playing with that thing, with the slider. You can tell whether or not it's weekend, because with weekend and with not. And now you can start to see like where these clusters are, why. And then of course you can multi-select on pickup hour or drop off hour, and you can actually go and really like play with this. And then of course, if you wanted to, export it. I'm not going to go through the last thing unless people actually really want me to. This is what happens when you select a nan. It says, hey, I can't convert a nan to an integer. And that's true. Okay. So we're not going to go through this unless people want to. And I'm opening up the questions and answers right now. And hopefully you enjoyed this portion. Actually, wait. Let me do one more thing before we do questions and answering. All this that you've seen is for the data scientist, right? In the middle of the workflow. But what happens for the people that aren't data scientists? What can you do? Well, using Plotly-API, we can create web apps. And this is an actual video of a web app. Let me make sure that you can hear my sound, actually. Share computer sound. So this is in real time, and I did kind of just want you to see that. But you're able, this is a single cell data analytics. It's an interactive visualization where you can highlight and click on different cells, and it will actually recluster for you right there in just as fast as you saw. So now you're actually, this is pretty much like multiple people can use this. It's clean because it's Plotly, right? And secondly, we have our friends at Graphistry. Crossfilter can also do graphs with version 16 with our awesome graph libraries, but that's mainly for people doing stuff in their workflows. When you want to do something awesome and really dramatic and really start to look into your graphs, you can click in on Graphistry, and I'm just gonna, we'll click in later, and basically it'll give you graphs that are interactable. You can hover, highlight, and look at different parameters within your graphs themselves. So while this is, and all of these are GPU accelerated by the power of Rapids, and these are things that like, hey, listen, from urban planning, if you were doing the NYC taxi notebook, to biomedical, to analyzing Twitter feeds or cancer research, which is what Leo at Graphistry has done before, and it's been really awesome to watch. You can then really start to allow others to take advantage of this and really accelerate their workflows. Now I'm completely done with everything that I have to tell you. Anything else is optional.
Awesome. Thanks, Tori. That was great. And I think we might be getting a little bit of feedback from you. But anyway, we've got another question in the chat. So here it is. You showed where you loaded a large CSV very quickly, but didn't it have to first be loaded into the CPU's memory, since GPUs can't access a driver or the network, just the CPU? Is that correct?
Yeah, so man, let me see if I can recall this fully correctly. Yes, it is one-time CPU read and sends it to the GPU. But you do this all the time with games anyways, and you know how fast that goes. So it is pretty fast. in itself off the PCI bus.
Awesome. Before everybody runs, I just wanted to take a quick second to announce something I should have announced at the beginning, which is PyData Global. I'm going to steal your screen first, your screen share for a second, Tori, and we'll come right back to you. Where is it? All right. The reason I'm bringing this up is because PyData Global is really soon. So it's like this, but on a global scale. It's going to be virtual. If you're in our Meetup group, we're going to host a virtual watch party. Some of us are actually going to give a presentation. There's a ton of really cool stuff. We recommend it. Okay, that's it. Back to Tori.
All right. Does anyone else have any questions or want to play with the visualizations or just want to see what else we can do as we like looked at the k-means clusters? I really wanted to glaze over that. I really had to glaze over that because I saw time.
Yeah, Tori, I had a question for you. Actually, two. I'm always trying to find cheap ways of doing things. Can I load the Rapids container on a Jetson AGX Xavier?
We do have, we are working on Jetson packages. That's something I should mention. If you have further questions or things that you want to know more about, especially as our community is big, I may not know everything, especially off the top of my head, but we have the Rapids community. If you go to rapids.ai/community, there's a Slack channel. And I can point you in the right direction and get people, like the actual people working on it, to come talk with you and help you through some of the things that issues that you have. We do have you can load something on, there's a kind of packages I think that we are doing for the Jetson Xavier, but we're not officially supporting them at the moment. So there's stuff I can send you, yes.
Okay, thanks.
All right. Thanks, Robert. I appreciate that.
So thanks, Tony. This was fantastic. I know people have questions. Maybe we just let the silence linger a little bit so people feel comfortable to ask them.
Oh yeah, and I'm going to start sharing my screen, just playing with stuff. So if anybody wants to go back to that. So one of the fun things.
Hey, Taurean.
Yep.
When is Rapids a bad choice?
Rapids is a bad choice when you have small amounts of data, or
What does small mean?
Small is probably like, I'm talking about like in the megabytes, like double-digit megabyte sizes. It's not really big data, and it's basically about how much time does it take to send that data to the GPU, to then and it can be processed faster on the GPU. There's other times Rapids is a bad choice, like when we don't have functionality from pandas. One of the things that I found recently was Pearson correlation that I needed for something. You do have to go to pandas. In fact, in that notebook that I showed you, we had to go back to pandas to work with matplotlib. It's never really a bad choice. You can still quickly transfer to and from pandas because we use the PyArrow format. But yeah, I mean, like, oh, and if you have limited GPU memory, that's one of the reasons why you saw in the notebooks that I had a few deletes, especially for the Blazing SQL. If you don't have much GPU memory, and it'll slow down a bit. It'll still be faster in many cases than GPU, but you'll have to use different tricks like RMM or others, and it just takes some time. You'll still be faster. It's just not as great. Part of the reason why I stuck with the 48 instead of like rocking the new 3090 I got, which has 24 gigs. Well, I'm trying to get this back up. Oh no, that's the wrong one.
We have another question in the chat saying, thank you for the presentation. Amazing. And then the question is, when your total data frame or data is too big for the GPU you have, do I need to manage that myself?
No, you will have some tricks. There's a default, and then you can optimize. And believe me, when you optimize, it goes plenty faster. There's several different ways that we can do it. In fact, we have a blog out right now on how to use larger than memory, how to process data that's larger than memory. Lots of our GPUs are like what, 16, 32, or 40 or 48 gigs that we use for data science. So imagine doing 250 gigs at a time or more. We have actually done terabytes, many terabytes. So let's go through those ways. First off, you can use Rapids Memory Manager. You can use Dask, where we actually work with Dask CUDA. We have a library that got swallowed into cuDF called Dask CUDF, which allows you to then start, having Dask scheduler kind of take over for you. We have UCX with RMM that works that starts to use the interconnects of multiple. If you have multiple GPUs, to then start making sure that they can process that data faster. But and then Blazing SQL has a really awesome ability to do. I forgot exactly what they called it, but Blazing SQL can do much larger than memory operations. They're amazing at like the way they handle it is pretty freaking amazing. And I'm actually going to look at it right now, the actual words, because I feel bad that I didn't have the words escape me. Out of core query execution. So you can actually, it uses Parquet files and it reads, and as long as you tell it where to create the table and create the table and create a context, it can then start to bring in the Parquet files really quickly. Now, if you notice, we're using CSV and large these aren't even large CSVs. I do like 20 to 50 gigs at times, or multiple 50 gigs. So Parquet keeps it small, and it makes it a lot easier for things like Blazing and Dask to kind of like handle these files. There's other things, and we can bring this up in Rapids AI Slack channel. Hold on, I'm trying to find the chat, and I realize I killed it myself when I killed screen sharing. There we go.
No worries.
Okay.
I can let you know if any more messages come up in the chat.
All right. Well, I figure since we have all of this, let's have some fun, because we are looking at the actual clustering. Does anybody want me to go on, or do we want to like close up and just like have some fun and watch some or send some links around? I'm really leaving it up to you. I'm at work for the next 30 minutes at least, and then it's overtime, and I enjoy I actually really enjoy playing with these data sets and analyzing things that basically people haven't been able to do. Rapids is, because of the power of Rapids, I've been able to participate in some really greenfield research and execution. I know that we've got a poster paper coming out with my friend Mo on transportation. Corey is on the line, and the insanity that he is able to do and push forth is amazing. Christian and the others from Blazing are here, and they have enabled a whole bunch of amazing capabilities for some of our clients and our enterprise clients. So, and then we haven't even started talking about things like Who's signal processing, our CyberLog accelerator, which allows you to do near real-time cybersecurity analytics, Who streams, that allows you to take streaming data from Kafka and bring it into cuDF and run through, NVTabular for knowledge graphs. The Rapids ecosystem just keeps going. We had gQuant for some time, where you were able to do quant analysis for our business and finance friends. And yeah, I've actually helped out build a few stock search modeling tools in my time here at Rapids, which is a lot of fun and keeps that money keep going, right? So
we have
anything else? What
yep.
workflows are you doing? Oh, my path. So before I was at NVIDIA, I was a researcher at a Future Technologies Labs doing future of work. There's a few of us actually who came from those labs. And at some point they asked me to join, and the timing was right. I mean, I'm grateful for them. It was a nerve-wracking decision because I got to play with robots. I got robots all around. And, you know, I had this really awesome family at where I worked. And then I joined NVIDIA, and I'm happy to say I've been really happy at NVIDIA. Recreated you know, kept on growing that family. And they've taken care of me. And, you know, I'm just hoping that I do great things as we continue. It's been a wonderful ride, because I see Rapids as a future work, stuff like this, where like Visual Excel, where now I don't have to go through and sift through 12.7 million rows. I can actually see it and play with it, and then decide what I need from it and what I don't need from it. And then to have Eric not poke me all the time in my talk, as I know he wants to do so badly. You know, these are great moments. Eric's looking up. He's like, wait, I could have done that? Are we still recording, by the way?
Yeah, we are. So
Yes,
what I was about
we
to
are.
say was, if you have any last official announcements that you want on tape, let's make them now. If not, then I will end the recording and we will officially transition to the after party where, you know, like we can just casually hang out. You can show us what you want and nobody's gonna get recorded.
I wanted to ask the crew, like, you know, a lot of you are here and, you know, some of you I haven't seen before, some of you I have. What sorts of workflows could you imagine yourself using Rapids for? Or like, do you have workflows or that you'd like to see or experiment with? Just write in the chat, I'll announce it out, or you can unmute yourself, either one. And of course, we're on recording, so if you don't say anything, that's going to be slightly embarrassing. So don't embarrass me, guys. Come on.
Hey, my name is Junior Sanchez. I think that data set that will be very useful for Rapids will be in the school environment, especially with all this coronavirus situation. There's a lot of data that's being piled up, and it's essentially very useful for schools to be able to access that data from coronavirus and be able to provide with accurate information in order for, you know, for the future to come and future students and so on and so forth.
Oh man, that sounds awesome. Actually, what's kind of interesting is that you reminded me my first big use case was the idea that like Rapids allows you to do full size data science in classroom time. Like, just think about it. This is I did this in about an hour of the actual visualizations, but showed it off. But like, how long did it actually take to run? You know, doing UMAP and everything, what takes 20 minutes in a minute would be, you know, it's pretty awesome. But then yes, coronavirus, the ability to take multiple data sets and really start to bring them together and start to analyze and see just all the nuances. That's I like that one, especially especially for schools and what they're dealing with right now. It's hard. A lot of my professor friends are suffering on this too. Anyone else? Compute COVID. Thank you, Corey. All right, I'm good to call it.